Now this problem is about impulse momentum theorem. According to impulse momentum theorem, when the momentum of a body changes because force is applied on the body and that force changes the velocity to an initial value to a new value, the momentum changes. If we get that change in momentum is equal to the impulse, and this is a consequence of Newton's second law of motion. Okay, let us read the problem. The problem says a body of mass 3 kilogram experiences a force F which varies with time t as shown in the figure. And here is the figure. You can see we have a force time graph. The force varies from 0 to a maximum value of 10 Newton in just 2 seconds. Then it maintains this, it remains constant 10 Newton for some seconds until it is 8 seconds. Then after 8 seconds, it suddenly drops to 0. That's the meaning of the graph. This means that the force acts on the object only for 8 seconds. Okay, what is the question? They said, what is the increase in momentum of the object after 8 seconds? Now, we have to remember that initially the object was moving with a velocity u, for example, and then because this force acts on the object with velocity u and mass m, it changes this u to a new value, which is v. So this means that the momentum, if we multiply this u by m, we get the momentum, initial momentum of the body. And when the force, due to the influence of this force on the body, when it changes u to v, the new momentum is mv. So if u is greater than, if v is greater than u, it means there is increase in momentum, and the increase in momentum is this final momentum, which is mv, minus this initial momentum, which is mu. The question is, how do we get this mv minus mu from this graph given? Okay, I want us to begin with the Newton's second law of motion. According to Newton's second law of motion, it says that force, the law says force is equal to rate of change of momentum. Rate of change of momentum. Okay, in symbols, this means this F is equal to dp by dt, where p is the momentum, F is the force, and t is time. So if we take this to here, we will get F dt is equal to, we are left with dp here. Okay, don't forget that p momentum is mv, so we can say this is d dm v. Okay, then if we take integral of both sides, meaning when you integrate both sides, you put integral here, put integral here, then this one becomes integral f dt, and then this t is from t1 to t2. Okay, t1 when you started the observation, t2 when the observation ends. So between this interval, what will be the impulse? You can see F times dt. This is a measure of impulse. And then on the left hand side, you have integral d mv. But then we know that mass is a constant. So for momentum to change, it means velocity has to change. And the velocity changes from u to v. Okay, from u to v. Since this one is a constant, we can take it out of the integral, and we have m out integral, then I have u here, I have v here, and then inside it, since I have taken m out, I will have dv. So this is equal to m. If I integrate dv, I will just have v. So this will be v, and then I have initial v small, and then I have upper limit here and lower limit here. So what I will do is, anywhere I will put now m, anywhere I have v, I will substitute this for it, then minus m again, then I substitute this u for v. So I have mu minus mv minus mu, which is exactly here. You see, mv minus mu. So this is the increase. This is my increase in momentum. This is my increase in momentum. And then the process tells me, the process here tells me that this increase in momentum is equal to what I have here. Can you see? So I can rewrite this as therefore increase in momentum. Increase in momentum is equal to what I have here, which is integral from t1 to t2 f dt. Now, which one is t1 and which one is t2? We go to the graph. You see, the force started acting on the object here, and it ended here. So this is your t1 and this is your t2. t1 is 0 and then t2 is 8. So we continue and say this is equal to integral 0,8 f dt. Now, remember that if we know the expression for f in terms of t, we can substitute it here and integrate with respect to t. Later, we substitute the upper and the lower limit. But if we are not given, we go to the graph and get the area under the graph. So this means that what I have here, what I do have here, this integral from 0 to 8 f dt is equal to area under graph. So I will now say this is equal to, I will simply say that this is equal to area under graph. Then I look at my graph. I will now look at my graph. The shape of my graph, what is it? Look at it. The shape of my graph, what is it? This looks like a trapezium. So I have to get the area of the trapezium. So let me label my graph. Let me call here O, A, B, C. And then I need this here. Okay. So I'm going to call this A, B, C, and D. So I need the length from here to here. How can I get the length from here to here? This the parallel side. So from here to here, if I want to know this length from here to here, I will now go to, since it is horizontal, I will go to the horizontal axis and say 8 minus 2. And this will give me 8 minus 2, this will give me 6. And then I need to know the vertical here, So the vertical here, since it is vertical, I will go to the vertical axis and say 10 minus 0, and this will give me 10. You see? What else do I need? From here to here, from O to C. I also need it, and this is simple, 0 to 8, so 8 minus 0, this is 8. So to calculate, this is the formula I use. I will use the formula for the area of a trapezium, and this is equal to a half into A plus B, close bracket, multiplied by height. And the A and B are the parallel side, meaning this side and this side. This is your A, this is your B. So I will say this is equal to half into my A. You see, my A is 6, this is my A, this is my B, and this is my H. So my A is 6 my A is 6 plus my B is 8. My B is 8 multiplied by my H, and my H is 10. You see that? My H is 10. So I continue and say this is equal to, you know, at this point I will just use the calculator, since we made the right formula, right substitution. So 1 over 2 is 0 0.5, so I will press 0 0.5, then I open bracket. You see that? 0 0.5, you open bracket and say 6 plus 8 close bracket, then multiply it by 10, something like this. 0 0.5, oh, I put 6.8, I'm sorry, so let me do that. 0 0.5 open bracket, 6 plus 8 close bracket multiplied by 10. See that? 0 0.5 into 8 plus 6 plus 8 close bracket multiplied by 10. Now press the equality sign and you have 70. So the change in momentum is 70. So I have 70. I can put Newton second if I so want to, because what I did here was to integrate this. So from force I have Newton, and from time here I have second, so my unit is Newton second. But I can also say that I can also write it as 70 kilogram meter per second, because I say change in momentum. Can you see increase in momentum is this? So this means that the unit of momentum and the unit of the impulse are the same. Here is mv, and the mv here, and the m is kilogram, and the v is meter per second. These two units are the same. Let me show you that quickly, but remember this is your result. Now let me start with the Newton second. Don't forget this Newton is the unit of force, and it is obtained from MA. Mass, the unit of mass is kilogram, and A acceleration is in meters per second squared. And then now you have second. You see this has a power of 1, so this will now be kilogram meter, the second here, minus 2 plus this 1. At the end, you see that you have kilogram meter per second, same as this one. So Newton second, kilogram meter per second are two forms of the same thing. What is important here, class, I only derive to show you how true is this process. But when you are writing exam, okay, where is the problem? When you are writing exam, don't bother about all this derivation. Just identify your A, identify your B, identify your H, and use this formula. Where is it? Use this formula. Area under graph is equal to, then half AB, half into AB close bracket H, then you make substitution and get your answer. Skip all these derivations, okay? I only derive them to show you how they obtain this and why this process is correct. Okay, thank you for watching. Assalamu alaikum wa rahmatullah.